Okay, my dear students, today we'll do exercise 6.5 and from it we'll do question number 7. So are you ready to do this question? The question is really very easy. If you understand it once, you can get the question easily. Okay, what is given here? That ABCD is a rhombus. I hope you know about a rhombus. Rhombus is a quadrilateral in which all the four sides are equal, and one more property it has, the diagonals of rhombus always bisect each other at 90 degree. Okay, so this is all about the rhombus. Now come to the question. In given ABCD is a rhombus, this is given in the question. Name I have given with myself, otherwise in question it is given that in a rhombus you have to prove that the sum of the squares of all four sides is equal to the sum of the squares of its diagonals. Right? So if our rhombus is ABCD, then what will be the given according to the question? The given will be in rhombus ABCD, AC and BD are the diagonals. Okay, and to prove, what you have to prove? You have to prove that sum of the squares of all four sides, that is AB square plus BC square plus CD square and plus AD square is equal to AC square plus BD square. So now we will have to prove this sum of the squares of all four sides is equal to the sum of the squares of its diagonal. So for proving that, let's say the diagonals intersect each other, bisect each other at point O. Okay, and we know that we have a property for the rhombus. Now I'm doing the proof. We know that we have to write first of all the first property of rhombus. In a rhombus, diagonals bisect each other at 90 degree. This is very important property and the whole question is based on this property, right? And one more thing I want to make you clear, that whenever you have so many squares in a question, at that time means the question you will have to do with the Pythagoras theorem. Okay, when you will just see the question is having so many squares, you have to prove something like that. That means you have to apply Pythagoras theorem. And for applying Pythagoras theorem, you should have a right angle. So in a rhombus, if you are not able to see the right angle here, so just think over the properties. And we have a property that diagonals bisect each other at 90 degrees. That means these angles, all these angles are of 90 degree, and these BO is equal to DO, AO is equal to OC. Bisect means in two equal parts, right? So now in triangle, I'm taking one of the right triangle here. Let's say this one, BOC. So in right triangle BOC, apply the Pythagoras here. The Pythagoras says BO square plus OC square is equal to what? Is equal to BC square. And this is according to the Pythagoras theorem, right? Now, can I write this BO as half of BD? As we have written here that diagonals bisect each other, and these two parts are equal. So I will just convert BO in half of BC, right? And OC we can write as half of AC. So this is half of AC. Equal to BC square remains same. There will be no change. Now 1 by 2 whole square means 1 by 4 BC square. Similarly, this will be 1 by 4 AC square and is equal to BC square. Now what we have to do? We have to take LCM here and we get it as, this implies BC square plus AC square by 4 equal to BC square. Am I right? Now take this 4 here in the right hand side. So we get BC square plus AC square is 4 times BC square. Okay, now what we have to apply, one more property we have for the rhombus, that all 4 sides are equal. So in spite of writing 4 BC square, what I have to do, I have to just write all the sides along with BC, because BC I can write it as, this is 4 times of BC. That means I can write it as BC square plus BC square plus BC square and plus BC square. Now we have all 4 sides equal, but AB is equal to BC equal to CD equal to AD. Why? Because ABCD is a rhombus. We know that, it is given. ABCD is a rhombus. So that's why we have all 4 sides equal. Now put all these values here in equation number 1. Let's say this is equation number 1. So if I am putting the values of BC in equation number 1, what I get, okay, I am sorry, I want to do a correction here. By mistake I have written BO square is not half of BC, it is half of BD. I am sorry. So I have to correct it. This is BD. This is also BD. 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 Okay. So half of BD square plus half of AC square is equal to BC square. Now I have taken the LCM. After taking LCM, it will be like this. And after just putting the values of BC, because BC is equal to AB, CD and AD. So for these 3 values, here I have to write this BD square plus, I am writing this one, this equation will be BD square plus AC square is equal to BC square, और इस BC की जगह DC square plus AD square and plus AB square. And this is what we have to prove. So this is all about the question, and I was sorry for writing here BC in spite of BD. So I'm just reminding the question once again. The sum of all squares of all 4 sides is equal to the sum of the squares of diagonal. So for doing that, we have taken this right triangle, we have applied the Pythagoras, then we have converted this BO as half of BD, CO as half of AC, and then after converting whatever we get, and there we have to put this BC as AB, AD and CD, because all 4 sides are equal. So that's all about the question. I hope you try to understand. Thank you.